All right, guys, let's take a look at the 1.2 homework. Now, before we get started on it, I do want to take a look at our journal because that's going to talk a lot about the different strategies we've been talking about. First of all, we see our first entry point here, how much you learn from theory, so reading, right, from practice, and from mistakes. So we learn a lot from mistakes. So we're going to make lots of mistakes this year because that's how we learn. Mainly, let's get to these multiplying with certain numbers. So like if I multiply by 9, another way to think about multiplying by 9 is multiply by 10 and then take away one group. Now with smaller numbers, this might seem like we don't need to do this, but just giving you guys strategies. So for example, 4 times 9, well, we could think about that as 4 times 10 minus 4. Either way, we get 36. So again, just a strategy we can use if we want. Multiply by 5s. Well, 5 times 6, that's 30. We should know that. Or I can double it. So multiply by 10 and then cut it in half. So instead of 5 times 6, I'm going to go 10 times 6 divided by 2. 10 times 6 is 60. Divided by 2, we get 30. Again, especially when we get to some bigger numbers, it might help them out. Again, these are just strategies they can use. If I multiply by 3, I can just double a number and then add it again. So 3 times 13, well, if I double 13, I get 26. Add one more group of 13, I get 39. Same idea. And these last couple right here with the 4 and the 8, these are big ones too. The double for 4. So if I want to multiply any number by 4, I can double it and double it again. So 4 times 12, we should know that's 48. But let's see this in practice. Or I can think about double 12 and double it again. So if I double 12, I get 24. Double it again, I get 48. 4 times 23, we might not have memorized in our heads, right? I don't. But I know if I double 23, I get 46. Double that 46, we get 92. And kids are really good about breaking down those numbers. And then 8, just double it one more time, right? Because 2 times 2 times 2 is 8. So let's do 15 times 8 basically in our heads. I'm going to do 15, double it, double it, double it. All right, so if I double 15, I get 30. Double 30, you get 60. Double 60, you get 120. So anytime you multiply by 8, you can just double, double, double. One more strategy we talked about, the double and half strategy. So anytime I'm multiplying, so our first example is 3 times 8. If I double one number and I cut the other in half, I'll get the same answer. So if I look at our example here, I doubled the 3 to get 6. And I cut the 8 in half to get 4. So in other words, 3 times 8 is the same as 6 times 4. They're both 24 in that case. Now, in class we talked about 25. Anytime you multiply by 25, if I double 25, I get 50. Double 50, you get 100. It's easy to multiply by 100. So whatever number we're multiplying 25 by, if I can cut it in half and cut it in half again, now I'm just multiplying by 100. And you might notice I even gave you a little sneak peek of standard algorithm. We'll learn that after a Christmas break. And then the only thing we have in here still, our next quote, Dan Campbell, our kind of inspirational thing to talk about. I value attitude over ability. If your skills aren't there yet, we can work and improve together. But if your attitude is lacking, you don't have a place on this team. Now, I'm not kicking you out of my classroom, but the idea is make sure we come with a good attitude. Because if your skills aren't there, that's fine. Cool. Now you know what you need to work on. We can work on that together as long as we have a good attitude. Anyway, those strategies, let's get to the homework. Because we're going to be referring to those strategies quite a bit here. All right, so we already got some red. So this is an example. The example was, again, anytime I multiply a number times 3, I can double it and add it again. We talked about that in our journal. Number 1, to find 4 times a number, Susan can double. So instead of doing 4 times 9, she can double the 9 and double it again. So the first question is, what is 4 times 9? They should know it's 36. And then B, they're just asking what's another way to solve it. Hey, it's a 9. You could use your fingers. I'm not really too worried about part B here on these. If they have another strategy, cool. The key is as long as we have a strategy. Number 2, to find 5 times a number, Kaylee multiplies by 10 and cuts it in half. Again, we talked about that in our notes. So for this one on A, it says write an expression with parentheses to show how she would solve it. So again, instead of doing that 7 times 5, We're going to double it. We're going to do 7 times 10 and then cut it in half. And then, yes, it's 35. And again, if they have another way, that's fine. I'm not too worried about part C on this one. Real quick, part B up here on number 1, if you'll notice, all they did is they kept the 4 and they broke that 9 into 4 plus 5. And then we multiplied 4 times these two parts. That's what they did in the example. I don't expect every student to write that, but again, just having multiple strategies. Number 3, given 9 times the number, Jasper multiplies by 10, then removes one group. Again, that's in our journal. So anytime you multiply by 9, just multiply by 10 and remove one of those groups. So to do 3 times 9, instead of doing 3 times 9, we can do 3 times 10, but we multiplied one extra 3, so we got to take that 3 away. Now we should know 3 times 9 is 27, so that's just another way to do it. And then they're just asking if you have another way you can do it there. All right, number 4, Brayden. Hey, hon, I'm just doing a video. Okay, that's fine. You can be in the background. Wife's coming up from lunch. I'm on a sick day today, so that's fine. You're fine, hon. Jonah was asked to add 4 and 7, then multiply the sum by 9. Which expression shows how he would do this? Remember, the sum is the addition problem. So if we're going to add 4 plus 7, we just got to make sure we're doing that first. And we can see the answer is A. That's in parentheses. We did that first. And then we multiply by 9. And then in class, we're going to talk about why are these wrong? Well, we definitely don't want to subtract. And this one, they kind of had it right. They had the addition and multiplication, but they had the parentheses in the wrong spot. So just keep that in mind, right? Parentheses first. We don't have to worry about exponents yet. And then we, multiply and divide, add and subtract. All right, Patrick needs to multiply 4 times 6, then subtract 12. Write an expression with parentheses to show how he would solve it. Well, if we're multiplying 4 times 6, then we're taking 12 away. That's what we would want to see. Now, it's funny how it says use parentheses, but then in the answer it says you don't actually need the parentheses, do you? Because orders of operation tells us to do that first. So we'll talk about that in class too. Number 7, Violet divided 21 by 9, then multiplied the quotient by 3. Again, if we're writing an expression, all we're doing is writing the math problem. We don't have to solve it. Well, if we're dividing 81 by 9, then multiplying by 3, well, we would do 81 divided by 9 times 3. Again, we don't actually need parentheses in this case because we would have to do left to right. So you can have them or not. Now, for number 8, we got A and B. So here's the deal. We see what the answers are, but I told the students I do need to see the work. So when we go over these in class, I want to see them breaking this down. What's 3 times 8? So for example, I should be seeing stuff like this. 54 minus 24. Maybe they can kind of do that mentally, or we could write it on the side here. 54 minus 24. You get 0. 5 minus 2 is 3. So just something like that. Same with this one. Just work it out. I don't need to see each part. Now we get to our challenge. So Raphael was given the problem 44 times 9. We just need to write an expression to show how we would solve the problem. We actually did this one in class and talked about a few different strategies. So the big one here is they're using that strategy we talked about earlier. If I multiply by 9, I can just multiply by 10 and take away a group. And then they're answering it from there. So yeah, so what they're showing here is we could multiply by 10 and then just take away 44. That's what they're doing there. In class also we talked about that 44, they're breaking it into 40 and 4. So if we want, we kind of think about these boxes. We got 40 over here, 4 over here, and we're multiplying both of these by 9. 4 times 9 is 36. Place my 0. 9 times 4 is 36. So then we would just add 360 plus 36. 6, 9. Oh, 3. Whoops. Bring down the 3. I was already regrouping in my head. So we get 396. So it's all about how our students want to do that. But we did that one in class. But again, just having multiple strategies. Let's get to the next page here. Example up top. To multiply by 5, Marissa multiplies by 10 and cuts it in half. Again, they're just kind of using these strategies. Number 1, to multiply by 12, Carter likes to multiply by 10 and then by 2. So what he's doing is breaking this 12 down into 10 and 2. And then here's kind of what he's thinking. So in this big part, we're going to have 16 times 10 and 16 times 2. So breaking that 12 into 10 and 2, because that's a lot easier to do, right? So 16 times 10, that's going to be 160. 16 times 2, that's 32. And then, yeah, we're going to have to add up our two pieces, 160 plus 32. And see what the answer is. Again, I'm kind of helping you a little bit with this one. So for B, we know it's 192, but I need to see how we did it. And then again, an expression of what he did. He did 16 times 10 plus 16 times 2. And that's exactly where that came from up there. These boxes, okay? So we're just breaking that 12 down into 10 and 2 and multiplying those two parts by 16. So for number 2, to multiply a number by 99, so if he likes to multiply by 100 and subtract one group. So it's kind of like the 9 strategy. So we're going to shoot over a little bit and just get rid of one of these. So here's an example of her thinking. So what is she doing? Instead of going just 8 times 99, she's going to go 8 times 100, which is right here. This is showing 8 times 100. But she went over, so she's got to take 8 times 1 away. Well, if we solve that, 8 times 100 is going to be 800 minus, what's 8 times 1? That's going to be 8. So minus 8. And we see it's 792. So again, that's pretty quick you can do in your head. You know, I know it's old people, right? Well, 99 times 8. Let's do it this way, right? Do a standard algorithm. You could do some regrouping. Or, hey, just multiply 90 or 8 by 100 and then just take away 8. Just giving students some strategies. Next, we get to these boxes. So we're putting baseballs in boxes, working at the Amazon warehouse. Now, for the dimensions, this is interesting because this is different than the book's been doing it. So, students, if you're following this, how have we done it in class every time until right now? We go over, back, then up. So I'm going to actually change this answer key. So it went over 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, just making sure their 9 was right. So I would actually say 9, then went back 3, and up 3. So I bet students are going to have 9 times 3 times 3. Now I realize if you're watching this, well, it doesn't matter. Right. It's going to be the same number, but that's how the book has been doing it. Over, back, then up. That's just kind of how they're doing it. Next, we get to solving these. And this is kind of playing into some of those strategies, right? 2 times 13. If I double 13, I get 26. Well, 4 times 13, I just have to double this, right? If I double one factor, I double my product. That was also in our journal. I kind of skipped over that one initially for this video. But if you double a factor, you double the product. Again, they did the same thing. They kept the 13 the same. If I double a factor, I double my product. So I can figure out what 8 times 13 is by knowing what 2 times 13 is. Double, double again. Kind of what they're saying. And then how about 10 times 28? That's pretty easy, right? That's going to be 280. So if I cut a factor in half, I have my whole. So that's what they're showing them here. Now for this 15, how do I get to 15? Well, that's going to be 10 plus 5, right? So I can just add these two pieces together to get that. And then this is kind of just reviewing a little bit from over there. So just looking at these strategies. Number 5, find the products. Now in class, I told them all these answers are going to be the same. So yep, spoiler alert, they're all 80. But I need to see the work. And I did say this time I want you to follow the rules. Because if you're just multiplying, you don't actually have to follow the rules. But I said follow the rules on these 3. And then number 6 is going to ask you, which one of these do you think was the easiest? So it's just how your brain works. Do you want to multiply 5 times 2 and then multiply by 8? Do you want to do 2 times 8 times 5? Do you want to do 5 times 8 times 2? I definitely personally think one of these would be the easiest. And I think one would be kind of the hardest, but it'll be interesting to see what the students have to say. It's all about what makes sense in their brain. Same with number 7 and 8. Number 7, they're all going to be 420. In this case, we did 7 times 6 to get 42, 42 times 10. Okay, I need to see the work on how you got 420. If they just have 420, then I'm not going to accept that. I'm going to say, how did you get to that answer? And then number 8, which one was easiest? All right, number 5. Again, we're back to those boxes again. So again, we're boxing up some baseballs. So right here, for each of the following problems, assume that a ball fits into a 1 by 1 by 1 space. And then you can either use numbers, labeled sketches, or words to find the answers. Show your work. So how many baseballs would fit if I had a box that was 3 by 5 by 2? And again, you're just going to multiply these numbers out. Technically, you definitely do not need to draw a picture for all these. But again, we're going to go 3 by 5 by 2. That's kind of what we're thinking here. Yeah, something kind of like that. So if it's 3 units by 5 units, and it's 2 units tall, kind of bad example there. But yeah, you definitely don't have to have a picture there. You can just multiply those out. But that's how they would set up those boxes. They're going to go over, up, and down. Over, back, and up. And same with here. 2 times 4 times 5. I just need to see the work. And you can multiply in any order, so you don't have to follow the rules on these. 24. How did we get that? Well, we went over 2, back 2. So 2 times 2. And then 1, 2, 3, 4, 5, 6. That was 6 tall. So 2, 2, and 6. 2 times 2 is 4. 4 times 6 is 24. Again, I just need to see some kind of work. Okay? Over, back, and up. What are your numbers? Okay? We can see that's 96. How did we get there? Well, how far over, back, and up did we go? All right, these last couple, 7 and 8. Brad's hoping to find a package that holds exactly 48 baseballs. So we want 48 baseballs. Now he sees that the sides of the box in the storeroom is 2 by 3. What's he hoping the other dimension is? So we know it's 2 by 3 times something. We want it to be 48. So the question is, what should that be? The answer is 8. We can see that. You guys show me how you got it there, okay? Kind of funny, the same answer, right? This time we want it to hold 46 or 64. Well, we know it's 4 times 2 times something equals 64. How'd you get that answer? All right, last question. We actually went over this together in class, but I'll go over it for the video here. Harris said that 15 times 9 is equivalent to 45 times 3 because you can multiply one dimension by 3 and divide the other dimension by 3. His partner said this only works when you double one number and halve the other. Who was right? Explain. So this double and half, we talked about it in our notes, right? So if we have 15 times 9, is it true that's the same as 45 times 3? Well, first of all, let's just solve this real quick. Let's see if it is right. So we'll do a little standard algorithm here, a little preview. So we're going to go 5 times 9, that's 45. 5 times 1, or 9 times 1 is 9, 10, 11, 12, 13. Okay, how about 45 times 3? A little preview standard algorithm. We're going to go 3 times 5. We always carry our tens digit over. And then 3 times 4 is 12, plus 1 more is 13. So we do see that it is indeed equal. And I told him too, hey, when you get into high school, you're going to prove. So if you proved it, cool. And it turns out Harris is right. Because what did we do to this 15? We multiplied it by 3. And we did the opposite to this 9. We divided by 3. So not only does it work if I double in half, it works with any number that's the same. That's why I had them right. So any number that's the same, I could multiply by 5 and divide by 5. It doesn't matter. As long as you're doing the same to both sides, it will still be equivalent. So there you go, guys. That is our 1.2 homework. As always, if you have any questions, just let me know. And this will get you ready for our first quiz coming up. All right. See ya.